The moon's diameter is 3,476 km. On the other hand, the Earth's diameter is 12,756 km. If we wish to express how many times bigger Earth is than the moon, we can divide Earth's diameter by the moon's diameter. So this means Earth is approximately 4 times wider than the moon. So you can fit about 4 moons across the diameter of the Earth. A good pair of objects that would make a good scale model of the Earth and the moon would be a basketball and a baseball or softball. The distance between Earth and the moon is much larger than either the moon or Earth. But how much larger is it? Well, if we divide the distance between Earth and the moon by the Earth's diameter, we get about 30. So this means that you could fit approximately 30 Earths into the space between Earth and the moon. The Earth has no combustion, which means it's not on fire. It has a lot of oxygen, and the lifespan would be way shorter if there was combustion. Earth's hottest temperature is over millions of degrees. The Earth has meteoritic impacts, which are 1/10 of the mass of the Earth every year that burns. The Earth has gravitational contraction, which is how fast the particles are moving. So let's say you wanted to make a scale model of the Earth-Moon orbital system. You not only need to pick appropriately sized objects to represent Earth and Moon, but you also need to place them correctly scaled distance apart. So let's say you use a 12-inch basketball and a 3-inch orange as your Earth and Moon. To represent an accurate scale model of the Earth-Moon orbital system, you must place the basketball and the orange 30 feet apart from one another. The geology of the moon, sometimes called the lunar science, is quite different from that of the Earth. The moon lacks a significant atmosphere, which eliminates erosion due to weather. It does not possess any form of plate tectonics. It has a lower gravity, and because of its small size, it cools more rapidly. Recent analysis show that the moon not only has surface water, but also enough water in the interior to cover the surface to a depth of 1 meter. The moon is a differentiated body, possessing a crust, mantle, and core. The near side of the moon is dominated by 2 types of terrain. The mare, which are smooth, dark lava flows that cover 17% of the moon, and the brighter highlands, which are the terrae, are completely covered in craters. The mare is named after the sea, the craters are named after the people, and the mountain ranges are named after mountaining. On the moon, a rille is a narrow channel that is on the moon's surface. Compared to the size of the Earth, the Sun, with a diameter of 1,392,000 km, is about 110 times bigger than the Earth. When comparing the Sun's diameter to the size of the moon's orbit around Earth, the diameter of the moon's orbit around Earth is about 769,000 km across. So the ratio of the Sun's diameter to the moon's orbital diameter is roughly 2. The Sun has these things called sunspots, and these are a region of the Sun's photosphere that appear darker than its surrounding because it's cooler. The Sun also has solar flares, which are an explosive release of solar magnetic energy. The Sun is often referred as a typical star, or ordinary star, because of its size, temperature, and brightness. 99.9% of the atoms in the Sun are hydrogen and helium. The Sun is higher in the summer and lower in the winter because of the ecliptic, which is the apparent path of the Sun around the Earth. The ecliptic can also change throughout the year. The Sun has coronal mass ejections, which are blasts of gas moving outward through the Sun's corona and into interplanetary space following the eruption of a prominence. The Sun has a rotational period of 24.7 days. Energy flows out of the Sun in the form of radiation. This flow is not smooth and uniform because each photon of radiation can interact with the atoms it encounters, and its path can be affected in some random manner. The photon's path becomes a very crooked line, a three-dimensional random walk, as the radiation is repeatedly absorbed, re-radiated, and scattered on its way from the center to the surface where it escapes into space.